So, good morning, all. I'm Vivek Kadam, a research scholar at Veermata Jijabai Technological Institute, Mumbai, India. And I am currently working as an assistant professor in D.Y. Patil deemed to be university in Amravati Institute of Technology, Navi Mumbai, India. So, under the guidance of Dr. Surendra Bhosale, sir, my PhD is ongoing. So today, thank you for the organizers, sir, for providing us the platform, for showing us this work. So my title of this paper is a modified method for beamforming using covariance matrix in Mimo radar systems. So uh, please inform me if any interruption is there. Thank you. So this is the outline of my presentation. So first will be introduction to beam pattern synthesis and some focus on these Mimo radar systems. Then literature review regarding the work carried out in this paper. And third one is the proposed method description for beam pattern synthesis. Then I will discuss some simulation and results. Then in the end, conclusive remarks on the research work and some future direction for this works and the selected references for this work. So first, in beam pattern synthesis is the process to steer a beam in a particular direction when we expect utilization of power in a particular direction and we want to save the power in unwanted directions. So this Mimo antenna system is nothing but the integration between the array antenna elements and the digital signal processing techniques. So using these two, we can electronically steer the beam without having mechanical movement of the antenna system. So this technique actually enhances the system capacity as well as increases the accuracy, then angle resolution, and reduces the co-channel interference and noise interference. So for this digital signal processing tools, we use in beamforming techniques for the beam steering. So along with this beam pattern synthesis, different beamforming methods for radiating elements are designed for optimal performance. Then mainly utilization of power in the desired direction also generates the desired beam pattern. So we are saving the power which is not required to be utilized in the unwanted directions. So to do this, a covariance matrix approach is one of the mostly referred approach. So this covariance matrix contains the direction of invariable data and the magnitude distribution of this multidimensional space, which decides the closeness with the desired values or desired beam pattern. So these designing of this covariance matrix, we can formulate it as the optimization problems in form of the semi-definite programming or second order cone programming problems. And these problems can be solved using the convex optimization methods. So regarding this, a short literature review is presented. So some selected reference I am presenting here. Detailed references and literature review I have mentioned in the paper. So first paper is published in the IEEE transition, which the beam pattern synthesis via matrix approach for signal power estimation, in which the author has presented a semi-definite relaxation approach for the signal power estimation using adaptive matrix. So in this paper, we have found that this approach failed to suppress the side lobe levels against the strong noise interference. So somehow power is utilized unintentionally. So in the next paper, this transmit beamforming for Mimo radar systems using signal cross correlation, another IEEE transition paper. It shows the multiple transmit apertures with complete flexibility in the choice of the signal transmitted at each aperture. So this is the novel idea presented in this paper, but this paper does not include the wideband waveforms, which are essential for the communication and signal transmissions. Then third paper, another IEEE electronics letters publication, convex optimization based transmit beam pattern synthesis for Mimo radar. In this, the author designed a beam pattern matching algorithm for minimizing the cross correlation beam pattern, but variable power allocation depending on the detection range is missing there. The fourth one is Mimo radar transmit beam pattern synthesis via minimizing the side lobe level. This paper is published in the electromagnetic research. So the power approximation based method is presented in this paper, but this study does not go through the design process for the covariance matrix. So by going through this literature review, we have formulated one design problem to synthesize the beam pattern. So in this, the proposed method for beam pattern synthesis. So we all know that one of the major concern about the antenna performance is the efficiency. Antenna performance and efficiency is the power management, but somehow variable power allotment with respect to the distance from the detected target is still unaddressed. That the literature that I have followed. So reducing the power utilization according to the search range will not only save the power but also show remarkable reduction in the system cost also. So we have focused on this point in this proposed method. So we have modified a covariance matrix in such a way that the only required minimum power is utilized from the total available power. So the trace of this covariance matrix indicates the deviation from the desired value, and we will try to match the desired value with the we will try to match the obtained value with this desired value. So by designing this covariance matrix, management of power allocation is possible. So in this proposed method, we have considered a probed signal power at a particular location is indicated by this equation number 1. This A theta indicates the steering vector, and R indicates the covariance matrix. And this covariance matrix can be estimated by this x of n, and this x of n is nothing but the input signal that we are providing to this antenna. So now consider the beam pattern that we desire to achieve. So we are noting this beam pattern as a BP of theta, and the total transmit power constraint that are considered, and we have designed one we are considering one optimization problem as mentioned in this equation number 2. So this is nothing but minimizing the deviation between the desired one and the obtained one. And for this constraint, as we are talking about the power, we all know that power is always positive. So trace of R should be always less or equal to the C. Here C is nothing but
you have 2 minutes, Vivek. You have 2 minutes.
Yes, thank you, sir. So we are considering here C is a maximum power, and R covariance should be a positive definite matrix. So by considering this, we have considered this equation. We have converted this equation into unconstrained semi-definite programming problem as an optimization problem, and by adding this new variable D and modifying this covariance matrix as mentioned in this slide. So further modification we have contributed here is nothing but we have defined 2 variables, that is D1 and D2. So D1 is nothing but the C minus track of covariance matrix. So it indicates how much power transmission is not done. And second variable D indicates how much transmission is guaranteed from this approach. So by modifying this covariance matrix using these 2 D1 and D2 variables, we are formulating this equation number 3 as a new equation number 4. And this equation is solved using this MATLAB, solved in the MATLAB simulation environment using this convex optimization toolbox. So for this desired beam pattern, we have considered this conditions equation indicated in this equation number 5. So for these considerations and modification in proposed in this method for beam pattern synthesis, we got this result So I have mentioned one statistical values for different value of x. So from 0 to 1, I have varied I have varied the value of x, and for that we have calculated the average desired power, average obtained power, average MSE, and optimum value. So this optimal value indicates this optimization problem is solvable, and we are getting responses for this each value of x. So for x is equal to 0.2, we have got this a plot. So here indication is that if we are considering the minimum power that need to be transmitted, so our system is capable to transmit only that power as compared to the maximum power allotted to the system. So we are trying to save power.
You need to conclude.
Yes, sir. So these are the outputs of this simulation results. So in the conclusive remarks, I will say this modified covariance matrix offers the higher degree of closeness towards the desired beam pattern. These semi-definite optimization methods used for optimizing this transmitter power requirements. So it is possible to provide the variable power to the array elements according to the distance target distance range detected in the radar surveillance, and this will result in the efficient utilization of power. Hence, it will improve the energy efficiency and reduces the total system cost. So, in the future, this approach is extended toward the meteoristic approach for the beam pattern synthesis and developing the hybrid beamforming algorithm for real-time tracking. So, that's all. These are the selected references I have mentioned in this presentation, though in my paper there are detailed references are mentioned. So yes, that's all about my today's presentation. Thank you so much for giving me this opportunity.